Welcome to the Lightning Talks, day 3 of the Congress. We will have 5-minute talks. They will smash this red button and a countdown will run for 5 minutes. And at 0, we want the speaker to stop, even if the person didn't finish. And we do that by clapping really, really loud. And we can try this for now by just clapping loud. And welcome Alexis. Yeah. The red button. Ah.
Thank you. Okay. Red button. It starts? Okay. I'm going to just give you an overview of a legal innovation that is happening in Switzerland in the domain of digital fundamental rights. It's called the digital integrity of the human person. So the concept is very simple. You have a right to physical and mental integrity. It's already written in some constitutions or fundamental rights. And we just add the right to digital integrity to this, and it allows you to guarantee your autonomy, basically. It's a very simple way to add it into the Constitution. So I wrote an essay about it a few years ago. It's in French, sorry, but we've been working on this since 10 years. And we were thinking about possible implementation. So these are 2 texts. For example, the Charter of Fundamental Rights. It says everyone has the right to respect for his or her physical and mental integrity. And same in the Swiss Constitution, there is every person has a right to personal liberty and in particular to physical and mental integrity and to freedom of movement. So how do we add digital rights in those kind of constitutions? I thought, let's try just by adding 1 word. And just by extending the notion of integrity to the digital space to what is your data, for example. So we've been working this with Switzerland, and basically we've got some success. So it was voted last year in the Constitution of Geneva. It was adopted with 94% yes vote. Everyone was for it. In Neuchâtel, it was voted last month with 95% of yes vote. There's one small group that was against, fundamental Christian, who said, no, I'm sorry, you cannot have, the human person is a body and a soul. There's no data. You cannot have this. So they were against it, but otherwise the people were for. This is a bit the map of Switzerland right now of like how it is going on. Their work in Vaud, in Jura, in Basel-Stadt just started. And in Zurich, we had a initiative. People were collecting signatures. The Pirate Party was collecting signatures, and we got enough signatures about the right to digital integrity. Inside, there's other rights. The right to be forgotten is an existing right, but it's put in there. And the one that has struck the most the people in the debate in Switzerland is the right for an offline life. That means you cannot force someone, the government cannot force you to be connected. They should always allow physical access for people. And some other rights also. So here you have a website, you can look at it. All the different rights are really well described. It's in German, this one. And later on today at 5, I do a presentation, full presentation, half an hour at the CDC on the whole H. And after, at 2045 actually, I will do a workshop if you want also to add digital integrity in your local jurisdiction. There are ways to do it. And now there was already, the first export happened 2 weeks ago in Strasbourg. The City Council voted a resolution to include the right to digital integrity in their jurisdiction. So it's possible to add it in your place. Come and join me at 5. And then at 8 for a workshop, 8:30 for a workshop. Thank you.
Another warm applause, please.
Did it start?
No, hold it.
Okay. So I'm going to tell you a story about one vulnerability, really cool vulnerability I found in RDP. Now, I'm not going to talk too much about what is RDP because I believe that most of you know what RDP is. And hopefully I'll make it in 5 minutes because that's my limit. So first of all, I believe that some of you know this old tool called Procmon. Now, I was looking at the RDP protocol and I was trying to understand what's going on in that protocol. So I decided to open this very old tool. And suddenly I found something very, very old. Also in 2023, I actually found a DLL hijacking in MSTSC exe. And I was like, no way I found this old school vulnerability in 2023. Do we still have DLL hijacking in MSTSC exe? So apparently we do. But it's not that easy as it used to be. Because when I looked at the vulnerability, when I looked at the DLL hijacking, and I tried to use the regular technique of loading a DLL main inside that DLL that was loaded, but wasn't available in the system, I noticed that nothing happened. So I dig deeper, and then I saw some flags that are being used to load this DLL. And what I noticed is that this DLL that is being loaded was a resource DLL. Now, what is a resource DLL? It means that it's a DLL that is loaded in a manner which the DLL is not executable. It's loaded as read-only to the memory. Now, to get familiar with that, you probably remember this dialogue from back old times. So we do have another very old thing. Like we have the Procmon that we use, the old school Procmon. We have an old school vulnerability, DLL hijacking, and now we have this old school dialogue for loading resources. So this DLL essentially was a DLL that was only used to load resources. Now, so what can I do with it? So I digged into deeper to the DLL, and then I saw another deja vu. I saw some format strings being loaded in that DLL. This means that I can probably chain both DLL hijacking and format strings, a very old school and old vulnerabilities, and maybe to get some profit from that. So that's what I tried. I created a malicious DLL, put it aside to the RDP file because the DLL is being loaded from where the RDP file that you are opening is being loaded. Then the user opens the RDP, and then boom, I get an RCE because I do have the DLL hijacking and the format string vulnerability one next to each other. So I was wondering, how come no one saw it before? I mean, this is a very classic, very old school vulnerability. And then I realized that the computer I'm using is a Mac M1, which is an ARM system and not Intel. So apparently this vulnerability was only on Windows for ARM, which no one really actually used and no one actually researched. So I went ahead and I was wondering, should I get a full exploit? Should I report it to Microsoft? This is very classic, very cool. So we don't really have time. I believe we have about like 1.5 minutes left, something like that. So I decided, damn, I need to report it right away. So I reported it to Microsoft, told them that they really struggled to actually reproduce it because even they don't really know how to reproduce stuff that happens on ARM and not on Intel because all their machines are actually Intel and they don't really use Windows for ARM. But then after back and forth, they actually agreed that I actually found an RCE, and I got this CVE and also my first Windows RCE, which was very cool. Aside from that RCE, there were a few more RCEs that I found in RDP and other vulnerabilities, and you can check them out on my LinkedIn. Thank you very much.
Thank you, Dor. And the next speaker is Markus. Please welcome him.
Hello everyone, welcome to my talk about static security analysis tools for Java. To briefly go into the past, there were severe security software issues that you all know. For example, Log4 Shell was a famous vulnerability which was related to the famous logging library Log4j, which you could easily exploit by just giving it a malicious format string, such, for example, writing it into a Minecraft chat. And you also know maybe GoToFail from Apple, which was a severe security vulnerability, which was just 2 times this duplicated GoToFail line. So to help developers find and rectify these issues, static code analysis tools emerged. So static code analysis is basically you take the code, you analyze it without execution. The most basic one would be to just use manual analysis, but we don't want to do that. We want to automate it, and therefore we use various techniques that are similar to compiler construction, and tools emerged which actually do this. So these tools can be used for various things, such as code quality checks, coding guideline adherence, but what we're looking at is security. But you need to keep in mind that these tools produce false positives and false negatives. This is due to theoretical theorems from computer science, like, for example, Rice's theorem, which you might know. So I looked at various tools for Java. All these tools support Java. I categorized them based on 2 dimensions. Here you can see the first one. This categorization is based on the internal tool design, basically how the tool itself is built. And I will show you 3 tools in detail in a minute. And I looked at what features to scan for these tools actually support. So one thing we look at is coding standards, which is just certain guidelines, how you use the language itself, the language features, and you can check if you're adhering to that. Bug lists is just like categorizations of famous bugs, for example, OWASP 10 you might know, or CWEs. SBOM is tools that are related to generating software bills of materials, which is a list of your dependencies, and it supports scanning for vulnerabilities in the dependencies. Secrets is also famous if you use an external service or you use something like a database. You need credentials to connect with the service, and therefore your application needs access to some secret, and you don't want to hard code these secrets. API use is also a famous topic. The JVM and others offer dangerous APIs, which you need to be careful with, cryptography, for example, or deserialization, and data flow analysis, which is a technique in itself, but also is used explicitly to basically show you how data is moved across the application. And now I show you 3 tools that I brought with. It's Error Prone is the first one, which is by Google. It's programmed itself in Java, and it uses matcher interfaces. It has 51 of these matcher interfaces. Basically, these interfaces go through all the code and check for matches. And here's an example method tree invocation matcher. Basically, go through all the code, looks at where methods are being invocated, so basically methods calls, and checks if they are safe. In this example, we use dir context, which is an LDAP lookup interface that Java provides, and it looks for use of dangerous methods, which you can see on the slide. And this could be used to find uses of Log4Shell. And Error Prone also supports applying fixes and refactoring with these matcher interfaces. The next one I brought with is CodeQL, which is from GitHub, which wants to be SQL for code. Basically, you have these QL queries which run against all the code. They look like SQL. You have from, where, and select clauses. In this example, you scan the whole code for places where you read from a file, but also you set the file as world writable, which is dangerous to do in this combination. You need to be careful that the input you receive is actually sane. And in this case, you have the select clause, which tells you, like, write me a message in all places where the set world writable is being done. This is like CWE 732. And the last one I brought with is CogniCrypt, which is from Krüger et al. And Eclipse. And it scans the Java code for correct usage of Java cryptography. It has 2 components. One is for generating code that uses cryptography, and the other one for scanning. It has specifications that are defined in a special language called Krüsel. Here I have an example, and we use this for the key generator, basically. Yeah, thank you so much.
Thank you, Markus. And our next speaker is Anna.
Okay.
One more time. Repeat.
Oh, sorry. Hi. So, the other day we ran into Apple saying that iPhones and iPads are not general purpose computers. And we were like, what? So, we are the FSFE. We decided to just engage in the Apple versus EU Commission litigation. So we are intervening because Apple took the European Commission into court to just try to avoid DMA obligations. And we are the only civil society that is taking part in this, and we are trying to protect free software against Apple or monopolistic control. And yeah, so we are now trying to enforce the DMA, and these are some of our arguments. So we are trying just to prevent that interoperability is still there, because Apple doesn't want to have interoperability. And this is part of one of our legal activities. So at the FSFE, we have different legal activities. And for example, we are now trying to also work with device neutrality. We really have also campaigns like router freedom. We are trying to protect free software. But we have more activities. So this Apple is the main activities we have right now. But we have other legal activities for you, like the legal and licensing questions. If you're a developer, if you are developing a project and you don't know how to license it, you have questions about all the different free software licenses, you can just write us. There's also a FAQ at the website that you can check with the main common questions. But then also we have a legal network. We organize this neutral, non-partisan group of experts. It's a worldwide expert. If you are legal, you can also join, legal background, you can also join us. It's a closed group, but yeah, we try to promote discussion. So all these new topics, like artificial intelligence, for example, we always try to discuss also in this legal network with people working with technology and in their daily lives. And also, as I said, you can join. There's the link to join. We have also the Legal Education Day, that this is for people who are starting and developing, and they also have a lot of questions about copyright and licenses. You can check all the videos from the last Legal Education Day in media.fsfe.org. But of course, you can also write us. And then last but not least, we have reuse software. This is a software we also developed to help all of you. And it makes really easy, in 3 steps, really easy to license your project, different license, to also check the license of a project. KG is using it. German Aerospace Center is also using it, a part of the year. So we are having a lot of people really, we develop. You can also contribute to develop it, improve it. The link is there, reuse.software. But we do a bit more. And we also are part of the Next Generation Internet Zero program, that is an European program. And we also help projects with there also, again, with legal and license support. For example, projects we had before was a lot ProTax, Mastodon, Pertube. And yeah, that is all about our legal work. I hope you don't have a lot of questions. If you have, we are in a booth in Bits on Boime Habitat. You can come and talk to us. Also, we have other activities, public awareness, and also policy. But right now, our main one is this Apple litigation. And if you can, please help us. This is a super long-term thingy. You know how lawyers are. Apple lawyers have a lot of money. Apple have a lot of money. We don't, fortunately. So also, If you want, I'm gonna help us from helping with reuse, spreading the word about all our legal work, also, becoming FSFE volunteer, or just talking about this. Thank you very much.
Thanks. If we have in the meantime new speakers coming in, please gather on the right side. Now let's welcome the next speaker, Gabriele.
Okay. Hello? It's not working? Okay. Hello. I want to talk to you about a project related to simulation hypothesis. The idea of simulation hypothesis is that our reality is not real, is a simulation of another reality. My approach is not philosophical, but practical. My idea is to use video games, computer games, in order to analyze some part of this idea. My starting evidence is that some dynamics in, in games are similar to quantum mechanical effect. So my working hypothesis is that maybe we are in a simulation, and some part of quantum mechanics is an unwanted effect, because in several games you have planned effect and unwanted effect, unplanned, that are emerging from the game. So the idea is, if we analyze in parallel this type of effect, we can learn something about quantum mechanics and reality, maybe. So the easiest way to work with this idea is use ancient old games. So I'll talk about briefly with some glitch in Super Mario, and RNG in Classic Doom, and entanglement if I can, because 5 minutes is not too much. So as I said, there are in games there are plane dynamics. For example, gravity is a plane dynamic, but the implementation is not perfect. So you have emergent dynamics, unwanted dynamics that are used in several ways. One dynamic is in Super Mario. In Super Mario, there are several glitches. One glitch is this one. So Mario can clip into walls, seemingly randomly. And this dynamic is really similar to quantum tunneling. In quantum tunneling, a particle can go through a barrier, even if the barrier has energy too high. This similarity is not apparent. Also, there are mathematical connections, and also the way are used is similar. In gaming, this emergent dynamic is used by speedrunners, and in reality, they are used by engineers and scientists. Another part really important is RNG. RNG is present in all games. Is a random number generator that helps to increase complexity in games without too much computational cost. First of all, it's important to say that RNG is in line with the mainstream interpretation of quantum mechanics, that is Copenhagen interpretation, because in Copenhagen interpretation, you have that probability is not ignorance of something else, but is a core feature of a quantum object. That is true in games, because you have elements that use RNG, and below RNG, there's nothing conceptually. I want to talk about this element in classical Doom. In classical Doom, you have several times you call a random function. For example, this snippet. But I want to go to a single part of this snippet, that one. There is a random call and an end operator. The end operator works like a projection, because it projects in binary only some bits. And this similarity is interesting mathematically, because it's similar to what it happens in projective measurement in quantum mechanics. There you see the formula for a projective measurement in the for a qubit. So there are similarities, also differences, but it's possible to make, for example, Doom quantum or quantum-like. So you have a tool that is already developed that can be used to study quantum mechanics. And I don't know if I have time. Also entanglement. Some glitches are similar to entanglement, but are not perfect. Okay. I think I've the next ones are there. So any help is welcome.
Thank you, Gabriele.
Yeah.
Thank you. I will do that. Don't touch my laptop. Can you hold that for a second? Thanks. At some point we started to clap at 10 seconds. I think it's better if we start at 0 so we don't confuse the people. So let's start at 0 again. Thank you. And welcome.
Okay, so I'm talking about CO2 negative energy production. Sorry. Okay, so I'm going to talk about CO2 negative energy production, and I'll give an intro how it works first. So we start with cheating and take the sun as a CO-neutral energy source, and the sun shines on the trees, and the trees take the CO2 from the atmosphere and store it in hydrocarbons, wood basically. So the wood is basically CO2 and energy for our purposes. So the problem is that the trees don't store the CO2 forever because they die and rot, and the rot will release the energy and the CO2, and that's not good. So one thing you could try to do is to actually collect the wood from all of their trees and make furniture and construction beams and stuff out of it, but everything will break at some point and will rot or will be burned, and the CO2 will be released at the end again. So what we really need is a way to preserve the wood and prevent it from rotting. And ironically, you can do it by burning it. If you ever did a campfire, you will know that you have the burning wood on top and you have the glowing coal on the bottom. You just can go, take the glowing coal out of the fire, extinguish it, and you have chunks of coal in your hand. And those chunks of coal are basically coal crystals and more or less will never rot. If they are buried in the ground, they will have a lifetime of hundreds to thousands of years. So now we have a path from atmospheric CO2 to actual coal chunks we can have in our hand. And that means that the whole system is carbon negative, not fully carbon negative, but it doesn't release all the CO2 it initially took from the atmosphere. So, the energy part is pretty simple. You're making a fire, so you have thermal energy, and you can heat houses with it, you can warm water with it, or you can produce steam, which could be used for energy electricity. So, what to do with all the coal? Luckily, the coal made from wood, and if it's quality coal made from wood, it's actual fertilizer. So you don't have to get people to bury the coal. The people will pay you to produce the coal and bury it themselves. So we not only can have a CO2 negative energy production, but the people will actually pay you to do it. So basically, we have trees. The trees will, you take the wood from the trees, partially burn it, and take the coal out. And not all of the CO2 is released again. The green path here. Okay. So how practical is it? And it's really, really practical. It's an ancient technology, and actually coal burning predates metal smelting. So it's pre-Bronze Age technology. The only problem with the old-time coal burning is that the ways to do it were really toxic. So I decided to try it myself and converted my wood oven at home to heat my home. And I just take the coal out with a shovel, and I produce about 4 cubic meters of coal, which is 1 ton of coal, which is 3 tons of CO2 per year. So I have half of my CO2 footprint sequestered by heating my house. So my question is, why the fuck are we not talking about this technique? If you know where the error is or why it's not working, please tell me. If you don't know, ask your friends and find out. And my contact on Congress is 2978.
Hi. Hello, guys. Just for organizational issue, is Dennis Eisermann over here somehow? Is he here? Yes? Is he there? No? Okay, if he's not here. He's over there? Great. Okay, so it's not your turn now, but we need you in a sec. So please give a hand and make some really fun noise. Jessica. More.
Hi, I'm Jiska, and I'm going to tell you about fake base station detection with CellGuard. So, fake base station tries to get your location information or even intercept, manipulate your traffic or exploit baseband vulnerabilities. How it works is that, well, usually you would just connect to a base station from your network provider, but an attacker could put up a fake base station with a stronger signal, having some slightly different properties, but very close to the original one, and then your phone would connect to it. And with CellGuard, we aim to detect such fake base stations. It supports the latest iOS, and you don't need a jailbroken device, so you can actually use it on your iPhone. Even if you are super paranoid and have lockdown mode enabled, it works. And the way it works is through some kind of hack, which is the debug profile for the baseband and a sysdiagnose. So with CellGuard, you can view all the cell details to that you're currently connected, but you can also explore nearby cells that are available, and you can even see the packets exchanged with the baseband chip. On a technical level, that works as follows. So Lucas explained that in a talk last year in detail, but what happens is, for example, you would send an SMS, and when you create an SMS, this would be sent to ComCenter, and ComCenter creates a packet that instructs the baseband to, in turn, then send a signal which is the SMS, so we have something that is sent over the air. With CellGuard, you can just install it through test flight. So last year it was not available, but we have it in the beta now. A test flight is for the beta download. Then you can go to our website, cellguard.simo.de, click on the test flight link, and then you will have this invite to our app and can install it like any other app. After installation, you have some walkthrough because, well, it's a bit hacky, and that's why we have to help you here and there with the installation. So first thing you have to do is install a debug profile. So a debug profile just enhances the log level. This is super interesting, so there's a ton of these. Have a look into those if you're interested in iOS research. You can even airdrop the sysdiagnose and then go to the settings of your phone and install the profile, and then just follow Apple's installation instructions. It tells you that the baseband debug profile expires after 21 days, so you have to do this every 21 days. We cannot change this. This is how Apple built this. But CellGuard at least reminds you of reinstalling the debug profile every 21 days. Then you import the sysdiagnose by just pressing all buttons for a second. That captures all the logs from the past hours. And then you go to the settings and just pick the latest sysdiagnose, share it to CellGuard. So that's the kind of hacky part. And then import it in CellGuard. We have a Rust library that parses all the logs locally, so nothing is shared to the cloud or something, all is local. And then CellGuard shows you all the base station information and also verifies cells in the background. So all of this just happens on your phone and you can have a look into it. So with CellGuard you can really get a lot of low-level data about your baseband, even on a non-jailbroken iPhone. It's super useful to detect some fake base stations, but it's also an interesting research tool. So, for example, I used it to look into the satellite communication in the recent iPhones, which is also done by the baseband chip. And please install CellGuard, check it out. It's a super interesting project. We do have an opt-in study going on, so about fake base stations to uncover fake base station abuse. That would also be super helpful to us. And so here is the QR code to download CellGuard and get more information. You can also contact me if you have any questions about it. Thank you.
Thank you, Jessica. Thank you. And the next speakers are Rahix and Max and Max.
Okay, so for this year's Rust assembly, we wanted to build a big Ferris crab, Rust's mascot. And since we needed to transport it to Congress and we wanted to be as big as possible, we thought about doing it as an inflatable, so think gigantic pool toy. And we will now take you through the journey of how we did that. Okay.
Looks like the slides didn't get updated, unfortunately, so we'll have to freestyle this.
Yeah, okay. So no slides. So you see the crab up there. It's an inflatable. It's built with PVC foil. So we started out by making a tiny prototype since we never did that before. So we built it about this scale. And then we scaled it up by 2 steps until we had this thing, which now hangs above the Rust assembly, which is around 1.80 meters wide. And to build an inflatable like that, you need the PVC foil. So we just got tablecloth, a transparent tablecloth foil from the hardware store. You can just buy that by the meter. The one that we used is 0.2 millimeters thick, but the 0.1 also worked for the prototypes. You need something to heat the seams with. We used an iron. We also really recommend an iron. We tried a soldering iron. Doesn't work at all. Horrible idea. Don't do it. And then you, of course, need LEDs to make it light up. And so what you do is you take the PVC sheet and you trace the pattern on it. We did that by using a projector. It's very easy. You just place the PVC sheet on the wall, project it with the projector, and then you trace it and cut it. And then you overlay the seams and go over them with an iron. And there it's important to apply enough heat, but not too much. So moving it around a centimeter a second is, I think, a good thing. And then you weld the seams all around. And I will now pass you on for some learnings that we had.
So first of all, most importantly, then you need to add LEDs. We learned a few things that we want to share. First of all, when you make the patterns for your inflatable, make sure you make them in a way that you can lie them flat on the table for welding. Don't try to make anything where the seams are not able to be laid flat, like with sewing patterns, I think. That was very important. Then we also tried PVC glue. It is very messy. Iron works best for welding the seams. Get an iron that is good enough, that has enough heat. We found above 220 degrees is very important. The first iron we had didn't reach that, and then we had a lot of problems with seams ripping when we put pressure into it. Also, your compressor is not big enough, we found out. We carry the crab to the lock daily and kindly lend their compressor to refill it. Also, make sure that you are very careful with triple points where multiple sheets of foil reach each other. And then in the end, it's actually not that hard.
Yeah, exactly. I'm here to tell you, build more crap. Feel free. It's really easy. If we can do it, you can do it. You can check it out in person and actually see how it works at the Rust assembly table. And if you want to talk to the crap, there's crap.delightful.software. It's actually hooked up to the internet. And if you tell it something nice, it might actually feel a very particular way.
Yeah, then thank you. And the next speaker is Dennis Eisermann. A warm applause, please.
Thank you. My name is Dennis Eisermann. I work in the area of machine learning security at the University of Ulm in the Institute of Distributed Systems. Oh, sorry for that. And these images are not recommendations for the next logo for the Chaos Communication Congress. Instead, they are kind of attack which you can use against image classifier systems. In general, these attacks work like you put something into a machine learning model, you produce kind of a small perturbation, and then you try to get the wrong outcome in an intended way. So you have kind of a goal what the system should do, and you try to adapt the input to get an output for that. Famous examples are, for example, that you mislead autonomous cars, that they do pretty bad stuff, or bypassing, for example, facial recognition. Typically, you have multiple steps that you want to do. At first, you look at a certain system and you have a bit of knowledge about that. For example, sometimes the model is open source, you can look into it, or you get kind of a commercial product like a recognition system for surveillance. And then you have to work with that, what you know about that. Then you need kind of a goal, so you want to have an intended behavior. For example, in case of recognition systems, maybe you don't want to recognize. That would be kind of a cool goal that you can work through that. And then you try to evaluate your attacks and move forward step by step that you optimize such a goal. And in the end, you want to deploy that in digital or in the physical world. I have an example for that. Here we can see they produce adversarial patches, so they try to change only a small area into the image, that they can take it with them, then they place it on this image and then they look how's the output. In the end we see it's unimportant which image is presented, instead we get always airplane as an output, but they're total different images. So there are kind of two types, sometimes digital, sometimes in the physical world. If you do it digitally, it's easier because you can change it pixel-wise. You can sometimes produce adversarial attacks. They look like a typical normal image, but they will be wrong interpreted by the model. Or you can deploy that in the physical world, like in this autonomous vehicle scenario, but then you have to change more because you cannot control pixel-wise the input because you have a camera in between, you have kind of lighting conditions and different things. And in the end, there are some reasons why this is working. You can do it in every step wrong. That's kind of a good thing for everyone who wants to do machine learning. So there are kind of pitfalls. You can collect the data wrong. Typically, some examples are easier to get than other examples. You can do the learning process wrong. Typically, you have kind of training and test data set, and they adopt as long as they have a good result in the test data set, but it does not generalize to reality. You have sometimes problems with the evaluation. There are kind of famous examples where you see, okay, you get always the right label for that, but the decision mechanisms are pretty wrong. For example, they can recognize dogs from wolves by the background because wolves are often in white background, but they do not recognize the wolf at all. But you get a lot of good labels and say, okay, the accuracy is super for that. In the end, also in the deployment, there are also a lot of pitfalls if you're in a certain environment where you want to use that. And for me, and that's the reason why I'm here, there's kind of a cool tool. It's called Adversarial Robustness Toolbox. You can play around with that, can deploy different attacks. It's easygoing, and if you're interested in that, look to that. It's kind of a cool project. And we will also do tomorrow at 5 p.m. a self-organized session. You can join us, can play with that around if you're interested in. And I think that's all from my side. Thank you.
No need to rush. Just a second. Yeah, our next speaker is Jessica again. Okay, let's go.
All right.
A warm applause.
So, I'm Jiska again talking about the iOS Inactivity Reboot. So, when you reboot your phone before the first unlock, it is secured by your PIN. There is some rate limit that makes it more secure, and a lot of data is encrypted. That means, for example, your phone does not connect to Wi-Fi, it does not show contact previews when you're being called. But after the first unlock, your phone suddenly connects to Wi-Fi, shows caller previews, and has a lot of more remote code execution attack surface. So you can imagine it like this. You have the lock screen. It kind of protects some stuff, but after the first unlock, you have a ton of apps running which pose a remote code execution attack surface. And furthermore, you're connected to Wi-Fi, LTE, you might have USB or something, and they also pose an additional proximity-based attack surface for attackers nearby. And, well, when should you reboot your phone? Because I said before, first unlock is more secure. Well, when it has been lost, when it has been stolen or taken by the police, or before you cross a border. Problem with the first three is you do no longer have your phone, so you cannot reboot your phone into the before first unlock state. So what Apple thought is a cool idea. They implemented a 3-day inactivity timer. So if you don't unlock your phone for 3 days, there's a counter going on. And then the phone reboots. So, well, you have 72 hours to find some bypass to that lock screen as an attacker. How it works is there is the SCP, which has the secure key store application, which checks when has the last unlock been. And then the kernel would trigger a reboot by asking the user space to reboot, and the user space initiates a graceful reboot. So this is hopefully the procedure that just happens if everything is good. And in addition, the kernel would also write some value such that it keeps that, well, the 3 days have been triggered, and it keeps the 3-day time. If the graceful reboot goes wrong, what happens is that the kernel actually panics. So if there is some attack going on, doing something in user space, the kernel ensures we really terminate no matter what. Then we reboot, and after the reboot, there is the keyback daemon, which sends an analytics event to Apple that it has been 3 days, which is pretty useful because in iOS 18, when they first released it, it was a 7-day timer. It is now a 3-day timer. GrapheneOS has an 18-hour timer, so maybe they will go even shorter depending on usability. For law enforcement, it means they have to act faster, so they have to do some forensic tooling with the phone within those 72 hours to at least stop the timer and then extract data. But it also has consequences for thieves, because if someone steals your phone, they are not just interested in the hardware itself, but for example, your banking information or other private information on it. And they could use outdated forensic tooling and just let your phone, like in the after first unlock stage, on the power bank for weeks or months, and then just buy outdated tooling on eBay, pretty cheap, and they can now no longer do this because the phone reboots, and then it's much harder to attack. So if you want to read more about how I reverse engineered it, I also have a blog post here, and you can also follow me on social media. Thank you.
Thank you, Jessica. You can introduce yourself and I do the slides thing, okay?
Yeah. Hi everyone, I'm Erwan from Brittany in France. It's okay, yeah. So hi again. So I'm going to talk today about large language models and their hallucinations, and that's a joint work with my good buddy Gilles. So as you may know, LLMs do hallucinate. So what's an hallucination for an LLM is actually LLM stating some fact which is factually incorrect. So how do you measure how wrong they are? Well, you bombard them with tens of thousands of questions and you just check if they are factually correct or not, and then you do the rankings of your LLMs. So that's the traditional procedures by developers to see if they are good or not. And then we figured out that finally we kind of know that they ate most of the clean internet before now, where they are sort of trashing everything by eating their own production. But before that, they were scrapping the whole internet, so to be trained on that, right? And actually, on the internet, there are repositories like the Connect repositories, Snap repositories, which are listing graphs or networks like web graphs, social networks, and so on. So they list these networks and their edges and everything. So we figured out why not trying to prompt them for known graphs to see if they manage to get a bit of what was that. So LLM is not a database, right? It's a probabilistic machine. And so you have to ask them nicely. So you do a prompt like that, like please provide me the so-called Zachary Karate Club graph, which is a very famous graph in graph analytics, as a Python edge list, print it. So we did that with 21 major LLMs like 6 months ago. And the cool thing is that you can do that on APIs because just one prompt. Otherwise, you need the LLM in local, or you're the developer, because you need 50,000 queries or so. So this is an example response. So there is text. Maybe they hallucinate there, but that's not our problem. What we're interested in is this list, what we exactly queried, so an edge list. And with this, we scrap that, and we can, of course, use some graph library tool, for instance, your favorite one, like, for instance, the networkx one, which is pretty fine. And we have to stress that prompt engineering is very important, because the LLMs sometimes they refuse to respond because they thought that Zachary was someone known or something, and this is private information. Well, actually, it's public information, right? An example output. So in A, you have the output of GPT-4o. So it's quite like the real graph. And so you have the real graph that you know. You have the output here in A. So what you can do is basic comparison. So you do the intersection. There are plenty of nodes, so that's pretty cool. And in C, you have the very interesting things, the added edges. So the edges that the LLM has hallucinated. So it's really in the mind of the LLM, we have a fact. It's not factual. So this is what happens. More interestingly, for some LLMs like Qwen2, for instance, manage to memorize the correct amount of nodes, but absolutely not the topology. So it makes a star, which is completely incorrect. And Llama 2 is completely out of his mind too. So it's a nice way to start seeing what they manage to remember somehow. And once we know that we can do that, my last slide here. We decided to query with 5 very small graphs from some library called the Graph Atlas. They are very tiny networks. And we do the average error they make. And in first column, we have the less hallucinating LLMs. And the cool thing is that it correlates with some hallucination leaderboard, which is querying not with 5 prompts as we do, but with 50,000 prompts. So there's 0.3 correlation. With way less stuff. So we're quite happy about that. So this means that there is some information by querying graphs to LLMs, and that may be used for further developments or stuff. More information here. Dankeschön.
Okay, thank you, everyone. The next speaker is kolAflash. You can come on stage. A warm applause for kolAflash, please. Don't forget to smash the red button.
Thanks.
Again, please. Yeah.
Okay, yeah, hi, I'm kolAflash. I'm a LibreOffice hacker, and I'd like to show you a little bit of stuff which has been going on around LibreOffice, running it in the web browser. And yeah, let's start with that. So yeah, basically some basic stuff. So there is something called WebAssembly. It's something the web browsers agreed upon, and it basically is something similar to what Java did. Oh, you actually used my older slides. I uploaded new ones, but doesn't matter. I can do with them as well. Yeah, it's basically something similar to the Java runtime environment, which started at the end of the 90s, but just instead now directly implemented inside the web browser. So you have some generic binary format, which is being built by the compilers, and you can run it pretty much everywhere simply inside the web browser. And you can actually just compile standard C and C++ applications and also other languages to this format. The thing is, actually, the application does not really know it's running inside a browser. It's just thinking it's being compiled to some CPU architecture, and now it's running on a Unix system or something like that. So what about I/O? Because the application does not know it's running inside the browser, there's no real file system or something like that. So that's kind of a problem. But let's get back to what's been happening at LibreOffice in the last years. So there's already something called LOVA. So that's basically LibreOffice. You compile it to WebAssembly. There's some documentation for LibreOffice, how to do that, how you can build your own WebAssembly binary from LibreOffice. This is using Clang compiler, which can compile to WebAssembly. And mscript is a kind of wrapper which is built around the binary. So that actually emulates some kind of Unix environment to the LibreOffice binary. So LibreOffice actually thinks there's something like a file system, which isn't, but mscript is kind of emulating this. So let's see how this looks like. That's been around for a few years. So that's basically just a LibreOffice here running inside a browser, in this case simply hosted on localhost, but the actual program is running inside the browser, not on the web server. Web server is only serving a static binary file, which is then being executed by the browser. But you already see here that something happened when somebody was typing this text, something changed the color, and this is actually some JavaScript code which did that from the website, which embeds this LibreOffice. So let's have a look at what's been done there. So there's a library called Theta.js, and this library actually enables to access some LibreOffice APIs from the JavaScript of a website. So LibreOffice has an API which has been there for many years. It's called Juno. And Theta.js is then wrapping this Juno into a nice JavaScript API. Juno, it's very much a C++ API. You need to do casting objects and stuff like that. So this is gone there, and you get nice JavaScript. And here, for example, a very small snippet you could put into an index HTML is actually you get some array buffer object, standard JavaScript object. Do a little conversion, and then you actually get a nice object. It's the FS object by the mscript environment, which actually makes you access this virtual file system which mscript presents to the C++ application. And there you can store a file in this virtual file system, and in the next step you can run JavaScript code which is then interacting with LibreOffice, and you can basically, this is some basic Uno initialization for this Uno API, it's the first lines, and then you basically tell LibreOffice, hey, look into this virtual file system, doesn't know it's virtual, but doesn't matter, and please load this file, and you have this file loaded inside LibreOffice in the browser. So I guess I got a few seconds left, so I can show you a few more screenshots. What you can do with this, for example, here, you can actually build applications around this. You don't have to do like an Office in a browser, like Google Docs stuff. But you can actually embed this into web applications. And here, for example, there's kind of a simple address book implemented on the website, and then you can transfer data from that address book into the LibreOffice process running inside the browser, and yeah, move data back and forth, control the UI actually, like disable all the UI elements there. Yeah, another example where there's actually some pinging happening. Yeah, thanks.
Thank you, kolAflash, and sorry for the old slides. And the next speaker is a bit nervous. It's Sofía. Please welcome her.
So, hello, I'm Sofía Aritz, and I was one of the last year winners of the Youth Hacking for Freedom competition and an upcoming FSFE intern. So, if you are 14 to 18 or know someone who is, this may be really relevant to you. So, what's Youth Hacking for Freedom? Youth Hacking for Freedom is a programming competition hosted by the Free Software Foundation Europe, where you develop your own project and there isn't any limitation for the idea. What's the only requirement? The project has to be free software. So, who can participate? Anyone who is between 14th and 18th years old, from Europe, not the European Union, and you don't need an European citizenship. So people like refugees are more than welcome to join the competition. So you can register here, and late registration is also allowed, which means that you can register after the coding period has started, but there isn't an extension to that period. So, the programming period goes from the 1st of January to the 13th of June, which is 6 months, where you have the time to work on your project and think about the ideas. You can register even if you don't have an idea, which I didn't at the time, but I registered anyway. Because there are monthly calls that are really insightful, where one topic is discussed, things like licensing or version control, things like that. Then there's room for questions where the participants can ask about anything they have in mind related to the topic. And then you get the chance to network with participants, with like-minded peers that are around your age, which is really great. Lots of friendships have formed there. And then the foundation also provides help. There's, you can ask legal and licensing questions, and the lawyers from the foundation will reply to you promptly. I had one question, and they indeed were really nice and really fast. You can also ask general questions if you have any problems with motivation, things like that. They cannot provide help with coding, but they also encourage that you seek help from other people, like teachers and things like that. And the most important part, have fun. That's the second requirement. Have fun while coding. So yeah, there are 6 winners with prices ranging from 1,024 to 4,096 euros. And also a trip to Brussels on a weekend that's really nice with lots of activities. So yeah, stay tuned, follow us on social media. We do lots of things, as my colleague Anna has already told you. And yeah.
Well done, well done. As you could see, no need for stress, you were doing fine. Our next speaker is Quiet Table. Please give a warm welcome.
Okay. So during this talk, I'm going to talk about Shovel, which is a tool that we developed in Team France for a CSC, which is a CTF competition. So I'm going to start by introducing what is an Attack-Defense Capture the Flag. So it's a game in which every team has its own network. Inside this network, all the machines from the players are going to be connected via a VPN, and they have access to Winbots, which is a Linux machine generally with multiple vulnerable services. The goal of such game is to hack into the other team's bots to steal some flags. Then you need also to protect your own bots, and you need to make sure that your service is still up. It's severe SAL. If your service is down, you're going to lose points. So there are many public events following this format, such as FOSS CTF, NORs, and SAR CTF. So when you're playing on the network, if you don't capture the network traffic, you're going to lose points, and you're not really going to know why you are losing. So you need to set up some sort of network capture. With the capture, you're going to know why you are losing points, so you can patch the service. You're also going to get an exploit that you may replay on the other teams, so it's a nice strategy. But patching may cause errors in the service, so now teams like to put IPS on top of the firewall to blacklist some payloads. It's a really effective way to have a nice defense. So yes, we need a live traffic analyzer. The problem is that it's very stressful to play an Attack-Defense game. So we cannot really use war chart because it's at the packet level and you are going to see too much data. So we need something that abstracts the flows, like the TCP and UDP flows. There is a tool called Tulip by Team Europe that already does that. It's quite effective, but it's not really robust against heavy TCP stats. So you can see here that we have a TCP flow in war chart that is black because the TCP is messed up with the current. So it's not really useful. So we developed a tool on top of Suricata, which is called Shovel. So it's a web interface in which on the left you're going to see flows in real time. On the right, you're going to see the Suricata dissection. It's quite effective. It's what's made to be very, to summarize all your data. It's free software available on GitHub. It's quite simple because it's based on Suricata. It's quite robust. It handles UDP, TCP, HTTP2, WebSocket, for example. You can capture the traffic with backup over IP, or you can mirror the network interface directly for low latency capture. And in the interface, you have some tags, like flag out, for example, when you are using a flag. And all these tags are defined with Suricata rules, like this. And these rules are compatible with IPS. So you can put this directly in the firewall. It's really effective. So I'm going to do two quick examples. So the first one is using libmagic. So when a file is uploaded, Suricata is going to run libmagic on the file. And you can differentiate between Microsoft exe file and an evil zip file using that. So it's really effective to block attackers. You can also block the user agent. Another example is to catch some RC. So by matching, for example, /bin/bash, you're going to see that you have some attackers putting RC in your service. So you can block directly in the firewall with RC. Thank you for listening for this Lightning Talk. Don't hesitate to go try Shovel. It's on GitHub again. And I'm open to issues and pull requests. Thank you.
Up next, we have Lucas. And he's brought something with him as a small demonstration. Finger crossed that it works.
Hello. Hello, my name is Lucas, and I will present you a tiny self-contained piece of home automation infrastructure that I built over the last maybe 10 years, all in all. And my motivation to do that is the microphone, I'm not used to that. I'm an independent hardware and software developer for home automation things. I have a lot of different setups, as you can see in the pictures, from very different use cases. And so I need an efficient way to keep all those things running over a long time. And I hope this platform can help others to do the same. So what are the challenges for long-lasting things? They need to be maintainable for a long time too, and not collect too much of technical debt for myself, because everything falls on my feet. So dependencies, oh, I see that's the old slides too. Setups must not have any external dependencies, because yeah, such a thing should run maybe decades, not just years. But on the other hand, it shouldn't be frozen. I need to be able to deploy firmware updates, think security updates for the platform, and it needs to have good network support, because if you have a lot of fancy installations, you don't want to go to on site. All of those, if something needs to be maintained, so you need remote access and things like that. So what's the approach I came up with? The projects use all the same firmware. So in the beginning, I had different builds for different things, and by now I have a single firmware that runs on this, that runs on all the things you saw in the pictures, and strictly separated from that the configuration about the hardware details, what LEDs are connected, and so on. And in particular, the entire project logic is in a script that can be, and that's the important thing, created, edited, debugged, maintained locally on the device, on the target. You need no more than just the network connection and the browser. So what it is consists of, it is based on OpenWRT Linux, which is great for that because it's tiny, it's designed for 24/7 operation, has great network support. On top of that is a daemon that does all the home automation stuff, because that's where it originates from. It has a model of rooms, scenes, and so on. It has a web interface to just work with it and develop with it. It has a graphic subsystem. I hope you see something of it here. Has a built-in IDE, debugger, everything, and even has MaterBridge. So you can integrate it in the big smart home systems. And everything runs on very tiny platforms, 60 meg flash, 1 watt of power, this thingy, of course, without the LEDs. So that's not a feature list, but a feature ball. So you maybe spot some things it can do. And all of this is open source, a full build of OpenWRT with all things on top. You can find it on GitHub at the QR code, and feel free to contact me afterwards or by email. That's my main channel, but one of the others should do as well. No, that's it.
Who is still awake? Can I see some hands? Ooh, that's nice. Okay, quick announcements. Please don't leave your trash on the ground. If you leave, take them with you. We have bins everywhere. You don't need to run far. Second, don't forget to drink water. It's really important. And also don't forget to wash your hands frequently. We don't want you to get sick. Now, who is feeling like, these lightning talks, only 5 minutes, that's something for me. Can I please see your hand? Maybe next time we will see you on stage. I see 1, I see 2. Okay. Well, I do hope that next year we will see you here with us doing something really cool and interesting to inspire others to do the same the next edition of the Congress. Please welcome Felix on stage. Come on, Felix. Don't be shy. And don't forget to press the red button.
There we go. So, good morning, kind of. My name is Felix. I just finished with my PhD with the Fraunhofer Institute in Dresden. And at this Fraunhofer Institute, we automated all kind of large vehicles, for instance, this field machine or this truck on the right-hand side, and also smaller machines like this mower robot here. And during my PhD, we always came to the question, we had a lot of expertise in how to automate the vehicles and how to use frameworks like ROS to do that on the vehicle side. But we always wondered, okay, if we have this automated vehicle, how do we actually send the mission to it? How do we tell the robot what to do? And that's why we invented the helyOS framework. So basically, when you deal with such a mobile machine project, you have all kind of different fields of expertise that you need. You might want to have a user interface. You might want to do some fancy route and path calculation. My PhD topic was actually coordination for multiple robots. So that is on the right-hand side. And then also the robot engineering itself with all the sensors and stuff. So in order to actually conquer this big project, you need a lot of things in between, actually the communication between the robots, between kind of a centralized control tower, if you want to have that, in order to link the user interface with the robot, for instance. So, as I already said, on the right-hand side, we already have some expertise. We are good in writing controllers, localization, whatsoever. And on the left-hand side, we want to have a user interface, and then we might want to use some cloud-based planners for trajectory calculation, whatever. And our question was, what is actually in the middle? We didn't find something which was suitable for us, so that's why we invented the helyOS framework. And since it's a topic which involves various different parties, we actually thought, okay, it doesn't really make sense to have that like proprietary software, but instead we decided to release it as an open source framework. So how does that work? Basically, you have this helyOS core framework in the middle, which is also cloud-based. And it basically links all the different parties with interfaces. So for instance, we have an interface to the planning services, which is just an HTTP REST interface. And then on the left-hand side, we have an basically GraphQL interface where we also provide software development kits to write your own user app for that. And on the right-hand side, we have a software development kit which you can use to connect your robots with helyOS. You can also use VDA 5050 for that, for instance. And then the entire magic in helyOS is that you can actually register that for a particular task, for instance, for driving from A to B, we want to use a certain microservice. So in this case, the orange one. So whenever the user creates the request, helyOS knows, okay, now the user wants to go from A to B. So we're going to ask the path planning service for that and then send the mission to the vehicle. That also works for more complex things with multiple vehicles. For instance, if you want to do the coordination, you just attach another microservice. And actually, with another user interface and another set of planners, you can also use it for other types of machinery, such as the field robot instead of the truck. Why is that interesting for you? So maybe you want to build a swarm of robots, such as the orange mower robots here on the bottom right. Then feel free to use helyOS for that. Check it out on GitHub. Basically, you can just follow the link helyosframework.org and it brings you to GitHub. And then you can use it for your mobile machine project. The only thing we didn't use it for was for the light panels we built for the CCC. So if you want to check them out, they're located in the club, aka lounge. So just follow the path to underneath the Radisson Hotel to check them out. They're actually based not on helyOS but on ArtNet. So yeah, thanks for your attention.
And now, for the final 5 minutes of fame, please welcome Tim. He is our last speaker of this lightning session. Please enjoy.
All right, so so I'm going to be presenting my remote desktop RDMA solution. I call it Telescope project. So a bit of background. There are basically two ways to do remote desktop. Either you do compressed remote desktop, which is what most solutions are. You get most of the benefits of compression, but you still get the artifacts. That's not something you can really avoid. You just don't have enough bandwidth. On the other hand, you can do uncompressed as well. You get pixel perfect quality, but you have a lot of drawbacks. Question is, can we do both at the same time? Meaning uncompressed and high performance and low latency. Main problem is if you use TCP and UDP. There's socket buffers, the Linux kernel networking stack is also quite complicated. And finally, because we're sending uncompressed video, this will basically never work over the internet. But at least we can do something about the first two using RDMA technology. So what is RDMA? Essentially, short for remote direct memory access. It's essentially full kernel bypass data transfer. It differs a bit from DPDK in that it's not completely passed through user space. You still need the kernel to do like connection setup, but otherwise you are communicating directly with the network card. Typically, we see this in HPC because using TCP when you have 800 gigabit networking does not really work, and you actually want your CPU to do like computing stuff and not just data transfer. But it's not a new technology. Many older data center NICs actually have RDMA support, like even 10-year-old NICs, meaning actually you go on eBay or whatever, you can find them pretty cheaply. So what do we do to bring it all together? We have a RDMA network library that we use. We didn't make it, these dark blue ones. libfabric, which is essentially an abstraction layer for RDMA stuff. And we use another project called Looking Glass, which does essentially what we want to do, but from virtual machine to the host. So the idea is that you dual boot, you don't need to dual boot because you can just have a Windows VM to run your Windows only applications, but you still have your Linux host. It dumps raw frames to a shared memory region along with metadata. We add a translation layer on top of this, and essentially that is our project. So the end result, I mean, you cannot really see it here, I mean, pretty far away, but it is pixel perfect, uncompressed, but it also maintains low latency and low CPU usage. So quick overview of the architecture. I don't have time to go over the whole thing, but essentially we use the unmodified host and client applications of the Looking Glass application. And it dumps these raw frames into a shared memory region. We send control like commands to this shared memory region, which the host and client can read. But for the actual sending of the buffer data, we use RDMA writes, which consume 0 CPU time. And actually, it's possible with some modifications to the actual host and client applications to reduce memory copies even further, and therefore latency. So is it practical? I would say no in most cases. If you don't think like, well, I have a use case for it where this could perfectly fit, yeah, then probably not. But it's a cool technical showcase. I, of course, say that because I wrote it. And I think there are still some niches where this could fit well. Like if you're a video editor, for example, because you don't have any compression, yeah, you don't need to worry about color accuracy. So if you want to try it out, the libraries are free open source, mostly under GPL v2. I think some are under like MIT as well. Yeah, so you can try it out if you have the hardware. Please don't run it over the internet. This is proof of concept stuff, so yeah, don't. But yeah, it's very early stages. I'm open to any feedback and also, yeah, pull requests. Yeah, so these are the QR codes for the repository and the corresponding documentation. You can also find this in the Lightningtalks section. I put links there as well for the libraries that we use. If you have any questions, because it was quite short, you can contact me in person, so I'm here, or via Matrix, GitHub, whatever, or email. Yeah.
Time is up, guys. What a wonderful list of topics and speakers. Can I please see who learned something today? I did. Wow, everyone almost. Okay, fine.